Which of the following units is equivalent to what? What is the unit of power? Power equals work done divided by time taken. The unit of work, which is joule, divided by the unit of time, which is second. We are going to make a little baby rearrangement. So joule second minus 1. Question 1, answer is D. Which row of the table gives two vector quantities? Vector, it means magnitude and direction. Acceleration, change in velocity. Over time, which is vector. Weight, gravitational pulling downward force. Weight, which is vector. Displacement, it's a distance in a certain direction. Vector, kinetic energy. Scalar, strain, scalar, velocity is vector, change in displacement per unit time, Young modulus, which is scalar, and mass, which is a scalar as well. So correct answer, which is A. In this question, the displacement time graph for a person running a race is shown. The examiner give us the data on the y-axis, x-axis, and he drew like kind of curved line. It's not a straight line. The examiner is targeting average velocity. Average, it means total displacement divided by total time. So I don't care about the gradient at all. I don't want the area under the graph. It's displacement after 4 hours divided by the time taken, which is 4 hour total displacement divided by total time. It's average velocity. So question 3, the correct answer is D. Quite a bit naughty question. The photograph shows a cable car hanging from the cable, and the cable car is in equilibrium position, so submission vertical forces, which is 0, and submission horizontal forces equals 0 as well if you are not accelerating horizontally. Which of the following forms a Newton third law pair of forces? Remember, we have in pair of forces, we have to have equal and opposite forces, and the forces must be same type of forces. The examiner said with the weight is a gravitational pulling downward force. So we want to find another force equal to the weight, but from the same type. So if you have a look at the choices here, air resistance, no, it's a contact force. And for gravitational force here, it might be the correct one. Have a look at C. Upthrust force displays it's a contact force. Normal contact force as well is wrong. So as the weight of the cable, it means the force from Earth on the cable. This is the meaning of the weight of the cable car, the force from the Earth on the cable car. And there is another force here, which is a gravitational force, but from the cable car on Earth. So this is the meaning of the same type of forces. And now this one agreed on Newton's third law of motion. So the correct answer, which is B. Question 5, the box slides down constant speed. So constant speed, it means submission force equals 0. Newton's second law, F equal ma. So the summation of the forces here, which is m times aa, is acceleration. So the acceleration is 0 as well. So it means the constant speed. The examiner we need to highlight, weight and resistive forces acting on the box. Okay, so let me draw the diagram here. We have a slope and there is a kind of a box. So the weight is acting on the center of mass and on the inclined or slope, and the kind of reaction or normal contact force from the surface. Okay, let me resolve or solve the weight into two components. So we have two components here with different color. So here we have a vertical component and this is the horizontal component. So this one here, we have a small angle theta and equal to this angle as well. So this component, we call it W with the side, so we call it cosine theta, and this component which is W sine theta. Okay, if you're sliding and there is no external force, so I have to though draw another type of force here, which is let me change the color here, which is the friction force here, which is Fr. It's kind of resistive force. Okay, so I change the sentence or the question into a diagram to make it easy for me. So now the resistive force Fr equals the horizontal component, which is W sine theta. The examiner said constant speed, so these two forces must be equal, no acceleration. Remember that Fr here as a resistive force equal weight, which is mg, mass times the gravity times sine the angle. The mass, by the way, it's constant. Gravitational field strength or acceleration due to gravity, it's constant as well. If you want to change the resistive force, the only factor you can change it, which is the angle between the slope and the horizontal here, the surface, for example. Okay, let me have a look at the choices for go from D, for example, to A. The component of weight perpendicular of the slope is greater than, I cannot use greater at all because he said constant speed. Component of weight perpendicular to the slope is equal to the sum of resistive force. Cannot. I'm targeting the component which is horizontal one. The component of weight parallel to the slope greater than, if it's equal to, I can choose this one. So the last one here, which is A, the component of weight, which is parallel, yes, which is horizontal and parallel to the slope, is equal to the sum of resistive forces. So the choice A is the correct one. Question 6. Person stands on a moving staircase. The moving staircase, which is the increasing gravitational potential energy. So delta PE or delta GPE, we have how much, sir? 5,000 joule, which is the gravitational potential energy in a time taken, which is 42 seconds. I can use these two values to calculate the power. Efficiency 0.63. The examiner is asking about the power input. Efficiency here in physics equal to total useful power divided by the total input power. You want what? Input power. So input power equals to total useful power divided by the efficiency. Easy. Efficiency is 0.63. Useful power is already given. He made a change, which is 5,000 joule divided by the time taken. So 5,000 divided by 42. Do not use a calculator at all. Here in Edexcel, quite easy. So 5,000 divided by 0.63 and take the 42 down, which is times 0.63 in the denominator. Look at the choices. C is the correct one. Quite annoying question for some students. Question 8. Student uses a wooden bat to hit a stationary ball here, which has a mass m. Okay, and as the bat hits the ball and the momentum of the bat decreases by delta b. The ball then moves with a velocity v. Okay, let me draw the diagram, make it simple. This is the bat. Okay, I'm not good at drawing at all. This is the ball which has the mass here. He said it's stationary, so times u, so initially zero momentum. But remember in physics, according to the conservation law of momentum, the momentum decreased by the bat automatically delivered to uh, the ball. So if the bat has a momentum here, which is delta p, there's a decrease in its momentum. So this one is the change in momentum, which is in increase as a value and is given to the the ball after the collision. So the delta p for the ball, so B here for this ball, it's M, the small ball, and times delta V because there is a change in velocity. So this one is the change in momentum for what? For this small ball or the first case or scenario. Then the student uses the bat to hit another ball, but quite massive one, heavy, greater mass. So this is the bat, for example, and sorry, so this is the bat and times a big mass, which is 3m. Stationary as well, yes. So initial velocity, which is zero. So the momentum initially here, which is zero as well. Then the bat decreases its momentum by 2 delta b. 2 dp decrease, as we did in the previous case. The momentum here of the ball of 3m is going to be 2 delta b as well, equals the mass, which is 3m. So it means 3 times the mass of the first ball times delta v, which is unknown. Okay, so I have two cases, change in momentum and change in momentum. So if I'm thinking about what? The velocity of which ball? Of the 3m. So shall I make it 2 delta v2 and this is delta v1? So let me make it simple. At least all my students can get the concept. So delta v1 equals change in momentum divided by mass. Okay? For delta v2 equals 2 delta p as a change in momentum in case 2 divided by the mass, which is 3m. So now I have two velocities. He's asking about the kind of ratio, so let me divide delta v2, so v2 for example. So now use this equation, equation 1 and equation 2. So v2 of the mass of the second ball divided by v1. So 2 delta p over 3m divided by v1, which is delta p over m. Cancel out the delta p with the delta p and m with m. So equals 2 slash t, 3. So v2 equals 2 over 3 v1. And if you have a look at the options, so the correct answer is B. Sorry, it's quite challenging question, my son. So please, all my students, take your time, take it slowly, easily, step by step. Think about conservation law of momentum and go ahead. Question 8, quite easy, relax. Two boats, forces. We have, sorry, forces these two boats A and B, and they're trying to apply the force on the ship, pulling the ship to the left side. So we have angles here with 31 and 27 degree and attached by a rope. So we're looking for a kind of a force along the rope here, which is FA and FB. So this is FA and this is this one, which is FB. To move forward, so component here, I'm looking for the horizontal component. So for A, we have two components. The vertical component here, which is FA vertical, and for here, which is FB vertical. But I don't want these components. I'm targeting the horizontal one here, which is FA hypotenuse cosine 31. From the other force, we have another component, FB cosine 27. I'm not sure which one is greater, by the way, but the most important, these are the two horizontal components. So the summation of F horizontal component of the total forces from these two boats, it's FA cosine 31 plus FB cosine 27 degree. Have a look at the choices. So the correct answer, which is C, I guess. Thank you. And a naughty question, but we can do it in an easy way. Just follow the steps. Student puts a piece of wood on top of a cylinder. He stands on the wood with his feet, distance x and y from the cylinder. The weight of the student is W. The examiner is asking how much is the weight. He didn't give us any number. He wants to see how much is the weight compared to the forces from both sides and the displacement or the distance of x and y. The force on of each foot acting on the wood here, and the wood is horizontal and in equilibrium. If I'm applying the one of the principles of moments like the clockwise moment equals to the anti-clockwise moment. So for example, for the clockwise moment or the anti-clockwise, sorry, let me start from the left side. So F times X here, which is a force from the side to the distance, which is X equals 2. The applied force from the other side, which is W minus F times the Y as a distance between the line of action of force W minus F times the Y, which is here. There's a center or this our reference point, and then F x divided by Y, so equals to W minus F, and then take the f to the other side, so w equals fx over y plus f. I think I reached the correct answer here. Have a look at the choices. So the correct answer, if you love the video, please leave a comment, share, like, subscribe to with your friends, and see you next video.